Question 3. An airplane is flying at a constant speed. So for the constant speed, that implies that acceleration is equal to what? 0. Okay? You should know that. Acceleration is equal to 0. Part A. The airplane is flying horizontally. The airplane's engines are producing a constant power of 5,500 kilowatts, and the airplane experiences a constant horizontal resistance force of 25 kilonewtons. Find the speed of the airplane. Now, in mechanics, remember I always say that you master the art of drawing, and then you allocate the forces that are acting on a given particle. So if, let's say, this is my plane here, so I can maybe do it like that. So it will have a driving force, and then it has a resistance force this way. They have given it to us as 25, then 1,000 newtons, kilo. Okay, that is that. Now, acceleration, we know that one is 0, but then we know that power is equal to the driving force here times the velocity. Remember, power is the rate of doing work. It is force times the distance. I mean, work is force times distance. Okay. Now, rate, that means we shall divide by the time, but distance over time is speed. So that's why we are having the speed here. And this force is now the driving force. So that is that. Now, what is the driving force? Because the speed is not known. Power is known. Power is known as 5500. Then we are supposed to add other 3 zeros. We are supposed to use watts, not kilowatts. Okay, so what is the driving force? Now, since acceleration is 0 and we know that F is equal to ma, then the net force is going to be the driving force, then minus this resistance force, which is 25000, then is equal to, already this one is 0. So we shall have a 0 here, meaning the driving force equates to the resistance force when a particle is moving at constant speed. So we shall have 25000 here times the velocity or the speed that we are looking for. So meaning this constant speed is going to be equal to 5, then 0, and then 0, then we divide by 25000. So what do we get here as our constant speed? 5500, then add the 3 zeros, divide by 25, and then the 3 zeros. That is 220. So 220 meters per second. That is that. Then part B, the airplane then ascends 300 meters in 50 seconds while maintaining the same speed. The resistance force is no longer constant, and the work done against resistance force in ascending 300 meters is 27,000 kilojoules. The mass of the airplane is 60,000 kilograms. Find the average power of the airplane's engine. If they say ascends, then it is going to be vertical in this case. So we are going to have something like this here. So let me do a simple sketch again. So this distance here, let's say the plane is now here. It was here at first, and it has ascended these 300 meters. So it has a driving force, and the resistance force is no longer constant. So there's also resistance to the motion. Okay, let me say there's that resistance there. Now, what I'm going to do here, I can use the work energy method. which states that work done by the driving force, so work done by the driving force minus work done again as resistance is equal to change in mechanical energy. Now, when this one ascends, so from here it is moving at a certain speed, okay? So it is maintaining the same speed. So here it has kinetic energy, and also here it has kinetic energy. But that kinetic energy is going to cancel out when I look at the change, okay? Because the speed is the same, so there won't be any change in kinetic energy. However, since we are having this vertical height generated, then here I will be having the potential energy. So meaning the change in mechanical energy is that potential energy. And you know that mechanical energy is equal to the gravitational potential energy, then plus the kinetic energy. Okay, so for this case, the change in mechanical energy is going to be due to the change in potential energy. Okay, now since I need the average power of the airplane's engines, I'll need to find work done by the driving force. Work done by the driving force. Remember, power is the rate of doing work. So if I get this work done by the driving force and I divide by the time taken, then I will be having the power. Okay, so work done by the driving force, then minus work done against resistance. It is given here, so we shall write 270, then 1000, then kilo, another 1000, then change in mechanical energy I told you is the potential energy, which is mgh. So m is 60,000, okay, then g is 10, then the height is 300. So meaning work done by the driving force is going to be equivalent to this 27 when it crosses and it goes the other side. So we shall have 270, then these other zeros, plus when we multiply here, 6 times 3, that is 18. So I will have 18. Then how many zeros are here? 1, 2, 3, 4, 5, 6, 7. So I add on 7 zeros on the 18. 1, 2, 3, 1, 2, 3. That is that. So work done by the driving force is which one now? When we add these two, 270, 0, 0, 0, 0, 0, 0, plus 180, 0, 0, 0, 0, 0, 0. Then we get 450 million, 450 million joules here. Then power is the rate of doing work, will be work done by the driving force, then divide by the time taken. So I'll get 450 million. Then we divide by the time taken, which is 50. Okay, because 50 can go here 9 times, so that will be 9 million. Okay, so we shall write our final answer as 9 million watts. That is that, or we can write it as 9,000 then kilowatts.